Awesome. Thank you very much for turning the music down. Good afternoon, everybody. Thank you very much for coming. I wasn't sure if anyone was going to be here, since it is the last slot of the entire session, which is always an insult to speakers sometimes. So I appreciate the gift that you've given me by showing up, and I promise I will make it worth your time. My name is Jonathan Carter, and this is the third session in the OData Roadmap in Action series, so to speak, today. How many of you went to the previous OData sessions by the amazing Pablo Castro and Mike Flasco? Awesome. Okay. So a couple of things I want to set up straight first is that this is not an intro to OData or WCF data services. It won't be very complex, and I'll do some context up front. But if there is anything that you don't understand or are not fully aware of, let me know afterwards, and I'll help fill in those gaps. And don't ping me for this not being kind of a one-on-one session. So what we want to do, as the session is called, Exposing Any Data Source as an OData Service. And so what we want to talk about in the next hour, and it's going to be mostly code, is if you want to take a bet on OData, which hopefully you all do, and you have some data source, regardless of what it is, how can you do that in a simple way and be able to do some prototyping or build kind of a service to get up and going, right? And the reason that we see this as important is many of you, no doubt, have been hearing a lot about open data, linked data, web APIs. And so there really is, from the industry perspective, a bit of pressure on you as a company and as a developer to, one, familiarize yourself with how to build web APIs, and two, as a business or a company, get your data out there. Just do it. And if you don't, you're not cool, right? But the problem is that that's easier said than done. And a great quote from a friend of mine at LinkedIn, he said that when we were building single applications, that wasn't too bad, right? You build a single WinForms app or an ASP.NET app. But now with the web and the trend to APIs instead of web pages, we're now talking about building entire platforms. And with those platforms and with that API comes tons and tons of clients, right? The demand for WinPhone 7 and Android, BlackBerry, Silverlight, so forth and so on, right? Now, the great thing is that if you take OData and you decide to make that the protocol for your API, which you should almost always do, because otherwise you're rewriting a wheel that very few people should, the clients come for free, right? So one of the greatest assets of OData and its ecosystem is the fact that there are clients for every platform. Silverlight, .NET, iOS, PHP, Java, Ruby, you're set. Right? So if you want to have broad reach and you want to hit that community and you want to have a great platform, you don't have to worry about the clients. But what about on the server, right? What are the options as far as if you need to expose your data, how simple is that? And in many cases it is, but sometimes people have one-off needs. So WCF Data Services is the name of the .NET client for OData. How many of us are familiar with this? Okay, most of us. So this shipped in .NET 3.5 SP1, and it makes it very simple to say, hey, you have some data, and you want to expose OData on top of that, and you're up and going pretty quick. So we have the scenario where it's ridiculously easy, and that is if your data is in a relational database, and you're using the Entity Framework, you have almost a very turnkey solution to get this going, right? And I say relational because EF doesn't just work with SQL Server. There are drivers for Oracle and so forth. And so that path is very great. And so the Netflix service that's live today that many of you might be familiar with, it's OData, uses this option. And it was very easy for them to get going. Now there's another side of the spectrum that is just crazy extensible and powerful. And so folks like SharePoint, where they need to build a much more robust service that takes complete control over scalability and all this stuff, there's a whole set of providers in WCF Data Services called IDSP that give you all the knobs and the tweaks in the world that you could ever need to go and do a lot of really awesome things. But with that comes a bit of complexity, right? You have to start thinking about custom queryables and creating a tree that represents your collections and resource types. And it's not bad, but in some cases, we might want to make it simpler for some folks. And so we've found when working with a lot of partners that there's actually this kind of in-between gap between really simple and really powerful and complex, where you have some data and you want to expose it, but you want it to be an easy experience. And so we work with some folks on their OData services like eBay and Facebook and Twitter or TwitPic and Wine.com. We developed a series of patterns that made building those services easy for them. And we feel like there's a lot of other people that can follow those same patterns and expose their data as OData in a simple way, right? And so what we did is we released this little extension to WCF Data Services called the WCF Data Services Toolkit. It's up on Codeplex today. Many of you may have seen it. But what we're going to do in this session is we're going to take a look at that toolkit and see kind of some scenarios that we can build OData on top of arbitrary data sources that aren't a relational database, right? And hopefully, any of you in the crowd, you can walk away. The takeaway I want you to have from this session is that if you want to adopt OData, you shouldn't feel like there's a blocker because the data source you have doesn't fit the mold, right? You should absolutely not have that problem. And so hopefully we can see some good demos to prove that. So that's all the slides I have. We're going to jump into Visual Studio for the rest of this thing. So what I want to do is show a couple of different scenarios of data sources that do not fit that typical streamlined, really easy data source. And so one of them is MongoDB, right? So I thought, hey, MongoDB is this very trendy, overly hyped NoSQL database that's getting a lot of, promotion. How many of us have ever heard of this? Okay, cool. More people have heard of that than they have of like any of our stuff, which just proves how overhyped it is. How many of you have actually used it? How many of you are lying? No, I'm just kidding. All right, so let's do this. Let's go ahead and say you have your data stored in MongoDB. And I don't want to convince you to move it because you probably have a good reason for choosing that. But I would love for you to put OData on top of it and have this great API. How could you do it, right? So let's go ahead and create a new project, and we'll build this from scratch. So I'll do a ASP.NET app. OK. So once I create that, let me also go ahead, not start up Instant Messenger. Wanted to start up PowerShell. So let me start up my MongoDB server just to have this running in the background. For those of you that aren't familiar with that, don't worry too much. It's just basically a thing that allows us to have schemaless objects that we can stuff in and out of a database. OK. So once we have our project, for those of you that are familiar with WCF Data Services, there's a couple of things that we need to do, right? And the first thing is define our model, obviously. What is the data that you're working with? So to keep things very simple, let's go ahead and just do person, right? Because we'll get very complex in a short while, so I don't want to make the domain any harder than it needs to be. Okay? So we'll make a new class called person, and we'll add the typical ID property, and we'll do first name, and we'll do last name, right? Okay. Now, we know that we're going to do a OData service, so what we want to do here is let's bring in the assemblies for, not NuGet. Let's bring in the references for WCF Data Services. Now I'm going to use the latest CTP. So let me go to my C drive. WCF Data Services, bin, great. For those of you that are using the version in .NET 4, you can just grab it out of the GAC. OK, great. Then also let me go grab the bin for the toolkit. All right, the DLO. Now we also have a NuGet for that, so if you are using NuGet, you can just go search for WCF Data Services Toolkit, bring it into your application. OK, so the first thing we need to do here is, for those of us that are familiar with data services, you know that it needs to have an ID for each entity type, and the pattern it looks for is either capital I, capital D, or person, capital I, capital D in this case. So I like lowercase ID there, so let me just override this and say the data service key is ID. OK, great. So now we're up and going. We have our model type. So the next thing we need to do is create our context. And for those of you that are familiar with Link to SQL and Entity Framework as data services, it's a very similar pattern where you have this object that represents your collections of data and what you're able to serve here. So let me just create another class, very simply. And we'll call this people context. And all we need to do is expose a series of iQuerybles, right? Just like with anything else if you're doing data services. If you're using EF with data services, EF queries are all iQueryable implementations, so they work out of the box. But if you're using Reflection or your own custom one, you have to do either an in-memory iQueryable or your own custom one. So here, because we're going to use MongoDB, we originally might have to say, oh, I'm going to have to create an iQueryable implementation between OData and MongoDB. But with the toolkit, I'm not going to have to worry about that, right? So let me just go ahead and say public iQueryable. Our data type is person. We'll call this collection people. Okay. And it's simply going to have a get method. And what we're going to do is inherit from a special class called OData context. This is part of the toolkit. And what that does is it gives us a few functions, one of which is called create query. And what that does is it will create a custom iQueryable for a specific data type. So in this case, person. I do not have to worry about that. OK, great. So the next thing we need to do is create our service, right? The actual WCF service that's going to be exposed over the web. Once again, none of this is new. This is all stuff you'd have to do in WCF data service as well. Now, instead of doing an SVC, I'm just going to create a CS class. So we'll call this people service. So I'm a big fan of having nice, clean routes. So we'll make this a OData service. And the type of that will be our context, in this case, people context. Okay? So as you know, there's this special function that you have to initialize your service. And if you use the add new item template for WCF data services, you'll get this for free. I'm just showing this alternative method. And this takes a data service configuration. Let me click away here to not have that IntelliSense. OK, great. And what we're just going to simply say is, let's go ahead and set the people collection to be able to do everything. And we're going to specify that this is a OData v3 service, because that's going to be the version I'm using. And that's it. Now, once we've done that, and one thing I want to show to people that is a big pet peeve of mine if you're doing WCF is to set up a nice clean route with ASP.NET routing. Because in .NET 4, there was integration added between routing and WCF to make it where you could get rid of that SVC file very easily. So what you can do is let me go create my global ASX file, kill out all this stuff I don't need. We'll say route table. And for those not familiar with this, this is an ASP.NET feature that allows you to essentially say a URL pattern that matches to some server resource, whether that's a web form page, a controller in MVC, or a WCF service, right? Now, we have a special extension method in the toolkit that makes this really easy. So let me just add that namespace. So once you add that, you now have this function called add data service route. So I can just say people service. Now, by specifying no parameter there, let me just zoom in a bit. What I'm saying is if a request comes in for the root, serve that request with the people service. In turn, the people service uses the context, which has one collection called people of type person, right? So once we have those classes in place, we're pretty good. So there's one other thing I need to do that you would get if you added the item template. So don't worry too much about this system.service model. Basically, what we need to do is just turn on the ASP.NET compatibility mode for WCF. OK, so if I just ran this right now, nothing would happen, right? Because you might be wondering, well, what is any of this doing? You have the service, you have this context, you have your type, but how is it going to know to get data from MongoDB in this case? Well, it's not, right? And so this is where we create the connection between OData and your underlying data source. And so the other special feature of OData context is this method called repository for. And what this does is the runtime, whenever a query is made for a data type, and this will be much clearer in a second, I promise, it will ask your context to say, give me a repository that is capable of returning data of this type. And so in this case, person. So we'll simply say, if the full type name being requested is the full name of the person type, then we're going to create return new people repository. Now that type doesn't exist, and so I'll just go ahead and generate it. Now what we'll see here in a second is that this repository is going to have no constraints as far as inheriting from a base class, using any specific interfaces. It's going to work all based on convention, and it's kind of interesting, right? So we have this class here, people repository. Let me make it public. And if I just run this as is, let's go ahead and see what we get. We'll do this iteratively, and hopefully by building upon that, we can understand kind of how this is working. So what we see here out of the box is our service document. This is very standard OData. If you were using data services with EF or any other programming model or data source, you would come to expect this. And what this is telling the client is that I have one collection that is called people. And to get to that collection, you have to append whack people to the href of the URL. Now, if I go ahead and say whack people, what I'm going to get is an exception that spells out what exactly it is we have to do in order to tell the runtime how to get data. So it tells us the method getAll cannot be found on the repository people repository. So here we're seeing, okay, there's this convention that the toolkit runtime, when it asks for your repository, it's looking for a method called getAll that will simply return the users, or the persons in this case, the people. And so all we have to do in our situation is understand how MongoDB works, our underlying data provider, and not have to worry about doing the custom queryable or working with the OData incoming request. So let's go ahead and implement that function. And it'll look very simple. We'll just say public IEnumerable of person, getAll, right? And within there, we just have to do our MongoDB code. So let's do one thing. There is a C# library for MongoDB that's really great called NoRM, which is fittingly named, considering it is kind of an ORM. Let me do a search here. Sometimes NuGet is a little flaky. Package source. Let me make sure I have internet connection. I had this a second ago. Luckily, I have the thing online or on my local computer. All right, let me grab this. So projects, Mercury, MongoDB, bin. Great. Okay. So NoRM, as I mentioned, is actually I'll just drop this on the. Is a C# library that makes interfacing with MongoDB very, very simple. So let me add a reference to that. Okay, great. So what we need to do here is let's make a connection to our MongoDB server. So in this case, it's very simple to do. We'll say mongodb.create. The connection string is 127.0.01. We'll just call the database demo. And then what we need to do is grab a collection type, Mongo. And also, and for the record, don't worry too much about what I'm doing. What I want to show is the illustration of the fact that the only logic I'm having to know to get this done is Mongo. So if you don't understand Mongo, it has nothing to do with this. It's the fact that I could wrap OData around anything. So we'll say server.database.getCollection of type person. Okay, cool. So then we need to add a little configuration for this to make this work for MongoDB. And we'll just drop that in. Okay, cool. So now what we can do is in our repository, to get all I have to do is say return collection.find, and that's it. So let me illustrate something. Let me open up the MongoDB shell and show you what's in there right now, if anything. So we'll say db.people.find. Okay. So I have in here 3 users. I have myself, Pablo Castro, and Mike Flasco. Right? Very simple. So without doing anything, I should be able to run this code, hit whack people, and I should see 3 entries because I've just simply wrapped OData around MongoDB. Right? So we'll come back to this. We'll say whack people, and there we go. Right? There's me, there's Pablo, and there's Mike. Okay? So we can take this even further and say, that's cool. Okay, in about 15 lines of code, we just wrapped MongoDB, which is an arbitrary data source. Don't get hung up on that. Could be anything. Do we get anything else for free? So let me say, hey, it'd be cool if I could also take advantage of other OData stuff. So say top 1, and that works. So the return query, the runtime, is also composable. So even though all that I said was, go grab all the users from MongoDB and return it, the toolkit runtime was smart enough to see the top one and say, OK, let me just grab the top one from that result. So here you're getting back me. Let me also go and do skip one, right? Top one, skip one. And so now we get back Pablo, right? So now I can do an order by. So if I say order by last name descending, and then say skip 2, now you get me, right? So you can do ordering, you can do skipping, you can do top by, you can also do projection. So let me go back to the root, right? So right now we're getting back all properties. We're getting back the first name, last name, ID. Maybe you only care about the first name. So with the toolkit, once again, you can say select equals first name. And notice we get that back, right? So let me go back to the code just to illustrate this. We really only had to write about 5 or so lines of code minus C# cruft for doing a class. And all of this code is specific to, in my case, my data store. So to come to this and to say, hey, I want to do OData, and I want to expose data in some data source, the only logic I had to know about is specific to me. So obviously, OData can't just know about every single data source in the world. But what if the experience you could have to build those services only required you to have the domain knowledge of your specific data, right? OK. So let's take a look at a few other examples. So in this case, what's happening is we're actually pulling down 3 records in this case and allowing the runtime in the middle tier to do the top and the skip for us, which is nice. But what if you want to do server-driven paging, for instance? So if somebody says, only give me 1, you only want to get 1 out of MongoDB. You don't want to get 3 and then only show 1. So you can also go ahead and take that over. So what I can say is, instead of just find, I can say, let's turn this into a queryable. And let's go ahead and also say skip. But then we say, well, OK, skip takes a number, so how do I know what they're requesting to skip? So you might say, OK, do I parse the URL? Do I grab the expression tree that was constructed and parse through that? Well, that's not very simple. Well, one thing that the toolkit allows you to do is, in addition to taking no parameters, you can take this kind of special context parameter that gives you the entire state of the request. So what I can say is make this an OData query operation. We'll just call this operation. And once we do this, this operation type will give us a whole slew of things out of the box. So for instance, we can say operation.skipCount, and then we can say take. Let me break this down to a few lines. Then we can say take operation.topCount, right? So let me zoom in. So now we're taking over paging, and we're going to do it on the server. We're getting a little bit smarter. So the toolkit kind of takes this iterative approach where it says, hey, we'll give you a nice experience out of the box where you'll get paging and sorting and stuff for free, right? It just works. But it might not be the best thing to do, so you might want to implement it yourself. So now if we do this, what will happen is the operation here will actually play nicely with server-driven paging that already exists in WCF Data Services. So if we go back to our service, for instance, and we say, you know what, I want to limit the page size for people. You can only get 2 at a time, right? So now what will happen is the operation, when it gets passed in, it'll let me know the top count by default will be 2. So let me go back to that and hit a breakpoint. Rerun this. We'll go hit people again. And instead of getting all 3 users, we should only get 2 back. Okay, just 2 people. So if we come here and zoom in, skip count is 0, as it should be, right? And then top count is 2. And that's just by hitting it. And the reason it's 2 is because we explicitly said you can only ever get 2. So now if I return this, if we go back to here, notice we get me and Pablo, but no one else, right? And so that's kind of nice. But the problem is how do I get the 3rd one? So you notice that I get 2, but I don't get any indication of how to get the next page. And so for those of you that are familiar with OData, there's this nice feature that will inject a link at the bottom that's called the next link that just tells whatever client is consuming the feed, if you want the next set of records, if there are more, this is the URL to request. And so in this case, we have to do something else. Because of the fact we're doing server-driven paging, the runtime doesn't know how many records there are to know if there should be more rows. So another thing we can actually do here is annotate a way to do custom counting. So if we go back to our person entity, we can say this collection has a custom way of determining its count. And so we then can go back to our repository, create a new function, public long person count. And all this now has to do is return how many people are there in general, right? So you have this thing that says give me people. It'll hand me back 2 if you page 2. But I need to know that there's actually 3. So we'll say return get download. Let's see here. We'll say collection.count, which MongoDB makes this very simple as well, all right? So now if we run this and we say whack people, it's going to call both of those 2 functions. It's going to call the first one to get the actual people, but then it's going to call person count. Notice it hit this, once again, completely by convention. And now this is going to return 3. And so if we come down to the bottom, notice now we get this next link. Now what's nice about that is to get any kind of custom paging scheme in data services, once again, you would have to implement a custom paging provider. It isn't too difficult to do, but with the toolkit, we saw this kind of paradigm over and over again where you had a collection that you wanted to do server-driven paging, but you needed a way to tell the client how many there were total. And so in this way, we get paging the same functionality that you would get in any OData service, but over an arbitrary data source. Okay? Now, one thing that's a bit tricky, though, is if I now grab this request, or this URL, and I say, OK, it tells me how to get the next page. Let me go request that and ask for it. So, OK, cool. It comes in here and gets the count. But I get nothing. And the reason is because the runtime thinks that it should take care of paging. So you're giving it back 1 record, but it's being told to skip 2. And so it skips over the one that you gave it, and it gives you nothing, right? So the way we need to do this is we need to tell the runtime, don't worry about doing paging or skipping in top. I'm going to do that for you. And so we can do that very simply. So if we go back onto get all, we can say the repository behavior for this is that we handle skip and we handle top, right? Very simply. So now what's going to happen is it's going to completely get out of our way. It's going to say, when I call you, when somebody asks for people, I'm not going to do anything for you for paging because I'm trusting that you're going to do it. And so now, if we zoom back out, run this again, and let me go ahead and take the breakpoint off of this so we don't hit it. We go to people. We should get the first 2, myself and Pablo. But now, if we get this request link, we're going to get Flasco. And there we go, right? And so that is a pretty simple pattern for doing kind of forward-only paging on the server, but with still very little amount of code, right? So the only thing we had to do is a get all and person count. Now, one thing I also want to illustrate is you might be looking at this and saying, that's cool that it's conventional, but what if I don't like the conventions? That's fine, they're overridable. So the way that the count works is you notice it's the name of the type appended by the string count. So if you like that style, cool. If you don't, you can override it. So if we come back to person, the collection count attribute actually takes a repository method parameter. I could call this foo, just to illustrate this. And so now if I came back and called this foo, it's going to still work, right? So all of the conventions that we have in the system are not locking you into our specific style. We try to be opinionated from the perspective. So here we get 2. Let me request the next page. And there's the 3rd one, right? So don't get hung up on the name. We tried to be opinionated in the names from the perspective of eliminating more work for you. So it's like, hey, kind of like MVC does, right? Where if you name your controllers this way and you put your views in this place, it'll just work. And so the toolkit is very much the same. OK, so let's run this again. So that's get all. That's how to get a feed. But what about getting a specific instance? So let's go back to people. So here, just like we know in OData, we have this edit link that shows us how we can edit or interact with an instance, and we know that the ID here is 1. So if I go up to the URL and I say, okay, give me the person whose ID is 1, I'm going to get another error that says the method get1 cannot be found on the repository. Okay? Once again, another hint. So we had getAll. Now there's another method that we can implement called get1 that specifies that we want 1. So let's go back to our repository. And hopefully I'm trying to illustrate this as very iterative, right? Like when you're building a web API, you don't necessarily have to do the entire breadth of features. Just do what your users are going to need, and as new needs arise, then you go implement it, right? So let's say all we cared about was a feed of users, then we're done. But if you want to say, hey, give me 1 user, well, let's go ahead and make that easy for people as well. So in this case, instead of an IEnumerable, we're simply going to create a function called get1 that takes a person, or that returns a person. Now you might be wondering, how do we know what person to get? Can we pull it from the URL? I guess. But that should be simple, right? So we also have, in addition to the operation type, conventions for passing URL parameters. So I can specify here a string ID, and that will hand to me the ID of the person that was requested. And so within here, all that I have to say is find 1. And this is just some MongoDB stuff. So we're going to say the ID of this thing is int.parse ID. Okay. So 1 line of code. Let's go ahead and run this. Let me put a breakpoint there, actually, just to illustrate. And we'll say cool, people. We'll say 1. So here it gets broken. Notice ID is 1. Let's zoom out and just continue. And here you get me, right? So I can say ID 2. It's going to get Pablo. Okay, cool. Now let me get rid of the breakpoint. So just like you got the query parameters out of the box with the getAll, you also can continue to whittle down on an object here with get1. So if I only want the first name of the person whose ID is 2, I can say people/ID/first name. And here I just get that back. If I want to remove the XML, I can say .value, and that works as well, right? So once again, the toolkit, and we're trying to figure out patterns and ways to say, hey, you should never have to worry about these simple things. Like, only worry about your data provider and your core business value, which I promised I wouldn't say, but right, that's like one of those continuous mantras that you always hear. You should only care about the business value, not the infrastructure. But it's true, right? Okay, so let's go ahead and take a look at a couple other things. So in this case, we've only done read-only. So we've shown how to get a feed, how to get a specific instance. What if you want to be able to add items and delete items from the feed? How simple is that? Well, luckily it's pretty simple. So what we can do is create a method called save that takes a person. Oh. And in the case of MongoDB, it's very simple. I can just simply say collection.save, pass the person. It's almost too trivial. So let me go ahead and run this. Now, in OData, right, inserts and updates are done as posts and puts, which I can't obviously do through the browser. So let's go ahead and crack open a little fiddler goodness, add a little more geek cred to this session, hopefully. And what we'll do, and just to illustrate here, so remember, we only have 3 users in the system. So I'm going to go, and let me zoom in here. What I'm going to do is say, we're going to do a post on the people collection, and I'm going to send it JSON, because of course OData supports both Atom and JSON, so whichever you're more comfortable with, you just got to make sure to specify the content type. And so here I can say the ID is 4, the first name is Drew, we'll put my manager in there, last name is Robbins. Okay? Now, I'm using Fiddler here, but you could be using any OData client. I could do this from jQuery, .NET, Silverlight, iOS, anything. I just want to illustrate this because this is as simple as possible, and so you can get an idea of how streamlined this is. So actually, one thing I also need to do is I'm running IIS Express, which you have to configure doing puts and posts. So let me just go ahead and change this to use Cassini here, because otherwise that would fail. I'm sure there's a way to tell IIS Express to accept all verbs, but I'm not sure how to do it, and it doesn't really matter. All right, so let me rerun this again. Now I'm using the dated Cassini. That's kind of crappy. Okay, so load that up. So now if I go clear this and make sure there's a breakpoint in my save of people repository, when I hit this execute, it's going to throw an exception. Let's see why. No connect. Oh, the port changed, yeah. Thank you. It's funny, I did that every time when I was practicing this thing. Stinking ports. Okay, so just to recap, we're going to say hit the root of the service, the people collection, and post this instance into that collection ID name 4, Drew Robbins. Okay, so I'll hit that, break, hover over person, ID 4, first name Drew, last name Robbins. Call one line of Mongo code. Cool. That returned with a 201, which is HTTP speak for. We just created that thing for you. Very well done. So let's go back to this service. Hit people. Jonathan Carter, Pablo Castro. Let's grab the next link. Drew Robbins. Right? So hopefully updates are as simple as well. One thing I also did not show is that $count works here. So instead of doing paging, if I wanted to say what's the overall count of people, it's 4. Right? So using all of the same OData conventions that you're familiar with. Right? We just want this to be as simple as possible. Okay, so let's do updates. So let me go back to this. And so now, instead of doing a post, I'm going to do a put. And this is OData speak, right? This is nothing new. We're just going to say, let's do a put to the person whose ID is 4. And actually, his name isn't Drew, it's Andrew. So let me be respectful of my manager here. So we'll hit execute there. Did I put the breakpoint? Okay. Return to 204, which is good. I don't think I'm even running the thing. Or am I? Here, let me run it from VS. Okay. Oh, yeah, it's running, but I didn't have the debugger turned on. That's why. Okay. So if I go to people, second page, there we go. Andrew Robbins. Okay, but now I'm like, well, I only put him in there because he's my boss. I actually don't want him in my system, so let's delete him. So what we can do once again is, actually we have to implement another function. So save does insert updates, as you can imagine. Now if you want to delete records, as you can imagine, you hit F10 on accident. You can simply implement another function, this time called remove. It'll pass in the person that you want to remove. And in the case of MongoDB, I just simply say delete the person. Okay. So I'll run this, run up the server, get that going. I think that's going to be the same port. It is. So in this case, and live mesh is going crazy, we can do an HTTP delete. We don't need the content body, the length, or the content type. So let's go ahead and clear that. So we're simply saying, do a delete operation to whack people ID 4. That's OData speak for delete the record whose ID is 4. We'll hit execute. Here we go. Here's the person. We'll run that. If we go back to filler, we get a 204, which is HTTP speak for we're not sending you anything back. What you just did was good, but there's nothing needed for you. So if we come back here and do people/count, we should now see 3, as we do. Just to illustrate, let me go to the second page, and we just only see Flasco, right? So there, within about 15, 20 minutes, we were able to create an OData service on top of MongoDB, right? So if you, once again, don't know what MongoDB is, don't worry about that. This is not a MongoDB session. What I wanted to do was choose a random thing, which actually most of you know what it is anyway, so that's really good. But if we go back to the code here, you notice that we have 50 lines, and half of that is C# syntax for making methods and so forth, right? So the complexity of creating an OData service is only as high as the complexity of your data provider. So in this case, MongoDB is pretty simple, thanks to the NoRM library, and so this is very simple, right? Okay, so that's MongoDB, let's take a look at another scenario, something that we've done very commonly. Let's take a look at wrapping an existing API with OData. So let me load up another project. So how many of us are familiar with Instagram? Fair amount. It's a really cool iPhone app that they're becoming smart enough to realize that they should have an API and have multiple clients instead of just one. And so we spoke with them, and they were like, hey, OData is really cool. What would an OData service look like on top of our API? Could we use our existing API and just add an adapter on top of it for OData? And with the toolkit, you can fairly trivially. So what I want to do is show off a couple of additional features of the toolkit. So let's look at this thing real fast. Should be very familiar after the existing demo. We have our service class. Simply says every entity set has all access. Let's look at our context. Once again, very trivial. We have one collection called users and one repository called user repository. And I've already implemented the get all and get one just because we've already seen how that works. Once again, in this case, instead of calling MongoDB, I'm doing OData adapting another REST API. So I'm calling this serializing JSON. Let me run this just to show how it works. And then we'll write some additional code to build on top of this. So here we go. We have users. Let me say whack users, and this will show an additional feature of the toolkit. So we're going to get an exception, and I'll run this, and we'll see what it is. So users cannot be enumerated. They can be accessed using the user's ID, as in one instance, or by performing a search like this, right? So you might say, hey, not every collection do we want to just give you everything. So if you have 1 million records, it might not make sense to ever have that. So you might say, hey, there's a search parameter, just let us know that. So once again, the same way that the ID and the other parameter conventions worked with the toolkit, what we can do is say users, we'll say search, lost in tangent, that's my name. And so just by declaring a parameter here of string search, the toolkit is smart enough to pluck that out of the query string and hand it to us, right? So here I can simply say, okay, great. If that's not null, then let's run this thing. All I'm doing is building up the URI of the existing REST service for Instagram, calling that. That passes back JSON. I turn that into a list of users. Oh yeah, actually. Let's see there. Yeah, this one does. Yeah, maybe it's Fiddler, but yeah, okay. Let me rerun that. Close all tabs. Oh. IE locked up. What? I thought fast was the new beautiful. All right, close this. Just kidding. That was probably my code. Okay. Actually, it was probably Visual Studio. So let me run this up again and say users, search, lost in tangent. Okay, great. So notice calls this in, download JSON data, project that into my type. And so now, here we go, right? Here's me. Once again, we can do the same type of stuff as we did in before. I could, oh, did not mean to do that. We could say search for lost in tangent and only give back the first name. Okay, it'll run in there, and we'll get projection, so there we only get first name, right? So there's simple get all. So let me then do a get one. So here's the ID. So we'll say users whose ID is this. And there's just me. Once again, I can traverse down, first name, value, okay. What's that? Oh, there isn't a first name, is there? Oh, it's no. Let me just say username, value. Okay, cool. So nothing new there. Now there's two things I want to illustrate here. One, it's a different data source, right? So just to clarify that. Now two, sometimes you might actually have different data sources that you want to turn into a common looking type. So one thing that's really great about OData is that it encourages structured data, right? Which is really the only type of interesting data, in my opinion, because otherwise how can you do any smart processing on it? And so in this case, we've only seen scalar properties where the person only had a first name and a last name, user here only has first name and last name. Well, what about if a user in the context of Instagram has a list of followers and a list of people they follow. But to get that data requires a call to another service. So if you want to get both, you actually have to do a bit of a mashup, right? And so the toolkit actually makes those kind of scenarios fairly simple as well. So let's go back to our user model. And so in addition to this, let's say, okay, let's get a bit smart here and say that we also have a user array called followers, and then a user array called follows, right? Because that is part of the API. That's very useful data. Now, as I mentioned, the problem is that call to the service that I make to request a user does not contain that list of followers or people I'm following. So what I can do, though, is I can annotate these properties and say that they are foreign, in that in order to get them, you have to call another service to make kind of a mashup. So what I can do is simply say foreign property, and we'll put that on both. And so once again, we're going to have another convention. Let's go ahead and run this just to illustrate the point. So I will say users of this ID. So by adding those two things, you'll notice I now, in addition to my scalar properties, now have these links, which are telling me these are associations of data. Once again, another existing OData concept. So it's telling me this user has followers as well as he follows people. So I want to be able to get this data, so let me go whack followers. But it's going to give me an error saying get followers by user doesn't exist. So once again, it's another convention for the name of the function. So as you can imagine, if we go back to our repository and we collapse these, I can simply make a function called getEnumerable of type user, and we'll call it getFollowerByUser. Now that user that we're getting, we can grab the ID from the same type of ways we've seen up to this point. And so there, all we have to do is build up the URL to call the REST service for Instagram, and then materialize those users. So let's say, in this case, once again, don't worry about this. I have a string up here that specifies what the URL is. So we'll say the user URL pattern, and then the ID, and then the resource we also want to get is followed by. Okay? So that's the URL we want to get. I just have a helper function that just download JSON data that I give it a URL. And then once we have that, we just need to project that type into our user. So we'll say we're project users, and I'll say JSON. Okay? So 3 lines of code. Let me put a breakpoint here just to illustrate that that is going to get called when we call followers. Okay? So we'll say users, me, once again, whack followers. And now when I do that, because I specified that that was a foreign property, it now says, okay, we can get that data, but we have to call another service to get it because it's not part of the same response. So once again, ID is 18734. We step through this. It goes and downloads that data. And here's the people that follow me. So let me remove that. Once again, I can do all of the same operations. What's the count of people that follow me? 10. I can do people that follow me, top 1, and so forth and so on, right? So now we're using the toolkit to do kind of a mashup type experience where another thing that people typically want to do with their OData service is design a nice, clean surface model that is exposed over the web, regardless what the underlying data looks like, and then allow the toolkit to let you mash that data up into the pretty form, which I'm doing here, where I'm saying, yeah, a user has this association called followers, even though that doesn't exist in the database or in the data store, right? It's really easy to think that when we're living in a pretty world of relational databases and you have foreign keys between things, that these associations are actually constrained by some way, but a lot of data sources don't. So you have these kind of soft relations, but you can create those here with the toolkit. So let me go and implement the get follows by as well, which we can do once again very simply. Because the navigation property was called follows, it'll look for a function called get follows by user. In this case, the URL is follows. So now we can go see the people that I follow by reusing the same code. I could do some refactoring on that later, but just to prove the point. So we'll say follows of me. And here's the list of people I follow. So how many people do I follow? I follow 9, right? Okay, cool. So one other thing I want to show is, you remember when we did the custom count on the collection of users in the previous demo? What if the Instagram API will only ever return to me 10 at a time of my followers, but there might be 50? How does the toolkit know how many there are to know if it should do paging? Well, once again, just like the collection, we also have a foreign property count. And so what this is going to say is that if somebody needs to know the count of these 2 navigation properties, you have to call an additional function that will supply that data for you. So if I go back to my repository, we can say public long count followers by user. So now it's a different convention. Once again, you can override this completely. But what it's going to say is count name of the navigation property by the parent type. So hopefully it's fairly intuitive, but if not, you can override this. And so within that, all we're going to have to say is I've got a function that I pass that just gives me the user. This is a dynamic type where they have, I can say counts, followed by. Okay? And so now, just to illustrate the point that that is going to get called, let's go up and say users, followers, count. Here we go. Passes in the ID. I go off, grab the user. The user has that property, and we'll get back 10. Right? So what this does, in this case, I might not need that, but it gives you that flexibility to say, if your underlying data source has different ways of getting the count, of getting navigation properties, of getting the count of a collection, you have that flexibility just by defining new methods on your repository and not having to worry too much about actually interfacing with OData or the runtime. So once again, let me just, to illustrate the point here, we can override the conventions of the names it's looking for at a very piecemeal way. So the foreign property takes a couple of things. So I can say parent alias equals foo. And so what that'll do is instead of looking for get followers by user, it'll look for get followers by foo. So you can then say, okay, what if I don't like the name followers? You can override the property name and call that bar. So now it'll look for get bar by foo. Or if you want to completely override it, you can specify the repository method and just call it get followers. And now that would work just fine, right? So I just want to keep reiterating the fact that any of the conventions that you see in use, excuse me, you don't have to agree with those or use those if you don't want to. You can override any of that stuff. Okay, so one final feature I want to show of the toolkit is non-textual representations. So it's very common that if you have an OData service, it isn't just text. So in the case of Netflix, we always say that Netflix is really a feed of boxed images, the art for the films or the TV shows. And then you also have metadata for it. Now in the case of Instagram, an Instagram user has an avatar. So it'd be cool if I could also view the image representation of a user instead of just the metadata. Now in traditional WCF data services, you could do this by creating a stream provider. But with the toolkit, we streamline this a little bit as well. So if we go back to our user, we can just do a couple of simple things. So the first thing we have to do is specify that this type has a stream, right? That tells the runtime, hey, this thing has a non-textual representation. And then we can choose to implement this interface called iStreamEntity. And it's very, very simple. All we have to do is 3 methods. It says, what's the content type of this thing? So in this case, it's going to be image/JPEG. What's the E tag, which we're not going to have one because you can't update your image, so it'll never be out of date. And then it's going to ask for the URL. So the stream entity is not going to solve every problem of streaming. If your image or your binary value is in a database or on disk, it's not going to do that. It's not going to help you there. All this is going to do is make it really easy for, if you already have a URL for an image or for some other value, then you can simply provide it. So in this case, we actually already have the profile picture property on this class, right? So by simply doing that, if I F5, go back to users, we'll notice a change on our response. So I'll go back to me. So now notice that we have this edit media link that points at whack $value, which is OData speak for, hey, you can get the binary representation of this thing. Now in OData 3, you can have multiple formats and multiple representations, but in this case, we're just being simple. So what I can do is if I now say, give me the value of the user whose ID is this, we'll get back my cheesy MySpace-looking avatar. I don't know why that's there. But anyway, so you can see how, with just a few lines of code, we got streaming, right? OK. So there are a few more features to the toolkit, but that's pretty much it. So the way we like to position it is that this should be seen as a futures or a contrib attachment or extension to what's in the .NET framework now. So WCF Data Service is by far the canonical way to serve and consume OData. But if your company finds the need to expose data that does not fit into that relational mold, but you really want to use OData, and you find that this pattern might be useful to you, then we want to make sure that your adoption isn't blocked, right? And in addition to that, things like paging, streaming, and then all the other functionality you get, like sorting and so forth, we wanted that to come simply out of the box as well. So a lot of these features, there's a lot of simplicity that's going back into the core product and will continue to go in there. So we would love to get as much feedback on this and whether this is useful to you guys, as well as WCF Data Services itself. So with that, hopefully that was useful to you guys, and you feel like that can make your life simpler. And that's all I have to show. So I appreciate it once again for you coming out, and I hope you have the rest of a great trip in Vegas. So we have a little time, so if you have any questions, please either go to the mic so for the recording. So this will be recorded, so to make sure that everyone knows how awesome you are for asking a question, please use the mic. Yeah.
Hi there. Two questions.
Yes.
First one, the example you have right here, does it do a redirect or does it restream? Does it load the URL and then serve it back?
Loads the URL and serves it back.
Okay.
Right.
Second question, is it possible to define a different entity for update inserts versus the reads? Like if some properties are read-only, for example.
So the question was, can you have a different shape for the updates and the reads? Not currently, but one thing I wanted to bring up is the toolkit is open source. And so there's a handful of people in this room that I've spoken to that are making changes to it. It would be very trivial to make that change, and maybe I'll do it for you. But yeah, we want it, if you like this and you want to add a new feature, download it on Codeplex and contribute back.
Thank you.
Yeah. Yes.
If you choose to expose your internal data structures, is there a way to hide some of the properties?
Is there a way to what properties? I'm
to
sorry?
hide, if you can add an annotation to a property so it doesn't get synchronized or serialized into OData.
Oh, so the question, if I'm correct, is you might have properties on a type that you don't want to be passed over.
Yes.
There is not a way to do that now. The simple answer would just be to project it into a type that doesn't have those on there. But we could simply add that, once again, open source. Yeah. Yes.
2 questions ago, his first one might have answered it, but
Okay.
You said the image comes out of a URL. If you have like an ASCX that goes and gets that image out of the database and feeds it back out as a response, there's no obstacle there, right? That should work fine.
Nope. I mean, the only problem would be from a performance perspective, you're kind of doing multiple hops, but that would work.
And especially if there's
Yeah.
like existing code that,
Yep. So there's definitely, the toolkit is kind of a way to bootstrap or kind of help you do proof of concepts for things. So doing certain scenarios, it might be faster to do like a pure custom provider, and instead of doing what I did with Instagram, where you're kind of wrapping another API. But in some cases, it might be fine, and you might want to just get something up and going to see how OData can work for you, get feedback from your customers before you make the investment of doing a completely custom provider. Yeah. Yes.
How would you go about setting the caching at the HTTP level in here?
So it's a great question. There's actually another feature I did not show of the toolkit, that there is a output caching attribute that you can specify either on the repository itself or on a specific method. So if you want to say get all caches for 5 minutes, you can easily do that just by putting an output caching attribute on there. Yep. There's actually a handful of other things that are in the toolkit as well, that if you go to the Codeplex page, it'll outline it all. Just didn't have enough time to say it all in an hour. Cool. Any other questions? All right, awesome. If anyone wants to come up and chat with me afterwards, and otherwise I appreciate it very much for you coming.